Yeah. Good morning, girls. In the yesterday's class, we have discussed about what is multi-threading and what is multitasking. So the main difference between multi-threading and multitasking is in multi-threading, you will treat uh, each and to say uh, program into you will divide each program into multiple threads, and thread is the smallest unit. Whereas in multitasking, a program or part is considered as the smallest unit, and I also said you why the threads are called lightweight, because they share the same address space. Whereas in multitasking, programs will share multiple address spaces where the control has to shuffle between these address spaces, so it requires more overhead, more work. So that is the reason they are a little bit tough. But whereas multi-threading is nothing but a program divided into small parts, so all these small uh, threads will have only one address space. So shifting or shuffling between these programs is very much these threads is very much easy. So they are very much lightweight in this thing. So we will see today how to create threads. So as Java is a complete object-oriented programming language, so everything has to be done in the form of a class and object. So everything you create, everything you use should be in the form of a class and an object. So how we are going to create threads? That is what we will see today. So creating threads in Java is much simple. See how these threads are implemented. They are implemented in the form of objects that contain a method called run. So the threads are implemented. I mean, they are given life as form objects. How? From a class. How, these objects, how they are created by creating instances to the classes, right? So the main thing which these um, objects should contain is a run method. So the run method is the heart and soul of any thread. So the main part of that makes up your thread is there are also other methods, but the most important part, which is very much essential for the working of a thread or the implementation of a thread, is the run method. So without a run method, a thread won't exist. So it makes up the entire body of a thread and is the only method in which the thread's behavior can be implemented. So the thread body or the work which the thread wants to do, all the steps or all the body um, or logic, whatever you call, has to be written inside this run method. So it makes the entire body of a thread. Okay, so this is how your run method looks like: public, void, run, and all the statements that this thread is going to execute, implement, and close it. Next, the run method should be invoked by an object of the concerned thread. So how this run method is called? It has to be invoked by an object of the concerned thread in which this run method is written. So first you have to write a thread, and inside that thread you have to write give an implementation to this run method. You have to declare a run method and write the implementation for it. And how the run method will start working: when an object to the class or to the thread in which this run method is returned is created. So the run method should be invoked by an object of the concerned thread. So this run method, it should be called by an object to that particular thread in which this run method is written. So this can be achieved by creating the thread and initiating it with the help of another thread method called start. So how you achieve this? So how will you call the run method? So you have to, in order to call the run method, you have to create an object. So how will you create an object? So to create an object, first you should have a class. So how will you create a class? I mean, nothing but a thread. Here, a class defines a thread. So this can be achieved by creating the thread and initiating it with the help of another thread method called start. So along with run, the one more method which you need is a start method. So there are basically two ways to create a thread. Why? Because of the limitation in Java that a class cannot extend more than one class. See here, since Java classes cannot have two superclasses, that means one subclass can be extended from only from one superclass. It can't be inherit. It cannot inherit its properties from two super classes or two parent classes. It can have one and only one parent. So because of this limitation, implementation or to create a thread, two ways are given in Java. Excuse me. Yeah, by creating a thread class. First one is by creating a thread class. So how do you create a thread class? So define a class that extends thread class. This thread class is the built-in class which comes with our Java package. So thread class and override its run method with the code required by the thread. So in this thread class, you will have a run method and that can be overridden, see override. So already existing methods body is written or it is what you say, replaced or overridden in its old code's place. You write another code like that. So override it's a run method with the code required by our new thread. So already it comes with some method or it can be empty. So by using that run method declaration, you will be giving the body here. So from where this run method comes? This run method comes from the thread class to which we are creating a extension. So not to this class, we are defining a new class which will extend this thread class which will contain this run method, and we are overriding this run method with our own implementation which our thread wants to execute. Okay, so this is one method. And next one is by converting a class to a thread. So we are creating a class here by extending the thread class, and here we are converting a class. We will declare a class and convert the class into a thread later. How? By implementing the runnable interface. So first we will define a class, then it implements the runnable interface. So what this runnable interface contains? This runnable interface contains only one method, that is the run method, that is to be so as we have already discussed, run is the heart and soul of the thread. So all the things what this thread wants to implement or do has to be written as a body for this run method. So this runnable interface will contain only one and only one method, which is run method, that is to be defined in the method with the code to be executed by the thread. So you will be defining this method, a run method, with whatever code our thread wants to execute. Why we will use this second method? When the class which we create here has to extend some other class for some other purpose. So if we extend here, if we extend the thread class here, it won't be able to extend the other class for its other purpose. So because there is a limitation in Java, one class can extend one and only one class. It cannot have two super classes. So to give this class an opportunity to extend some other class. We are implementing the runnable interface. We have already discussed a class can implement any number of interfaces, right? So and the class can implement an interface as well as extend a class. So um, depending on its requirement, it can extend a class later. But for that, to keep it free for that purpose, we are implementing it. We are converting this class into a thread through this runnable interface by implementing this runnable interface. So this is how you will create threads. Two main methods: by creating a thread class, by converting a class to a thread. Next, extending the thread class. So first thing, by extending a thread class, how do you create a class? So see here, where does this thread class come from? This thread class is a part of our lang package, which is a part of our Java package. So this thread class is a built-in class which is a part of our java.lang package. Okay, so um, we can convert our class into a thread class, or by extending a class by uh, writing the code like this particular class extends thread class, so that it gives us access to the thread methods directly. So this inbuilt thread class has a method. What is it? It's a run method. So this run method will be or can be used if this class extends a thread class. So these are the steps that we follow here. So declare the class as extending the thread class, implement the run method that is responsible for executing the sequence of code that the thread will execute, create a thread object and call the start method to initiate the thread execution. So first step, create a class. Next, write the code in the run method. So implement the run method, and to make this run method to execute, you have to create an object to this thread and call it by using uh, the start method in order to make the thread run, or to initiate the thread execution. So say class my thread extends thread. Okay, so you have a new thread called my thread. Fine. So you are implementing the run method inside this thread, public void run. Okay. So see here, this nothing. This will override to implement our own code, which this thread, our newly created thread, my thread, wants to execute. So this is how your run looks like. We have already seen. Next, how to initiate it, how to start this thread, and to how to make this thread work. So we have to create an object. We have already discussed. So define the class, implement the run method, and create an object and call invoke that object with the start method. So see here, to this thread class, we are creating a thread. So we are using the new keyword. So this is what is creation of the object is. So once you create the object, you are starting the, you are implementing the thread, or you are making the thread run by using this call dot start. See, to actually start, create and run an instance of a thread class, this is what we have to write. Create an object and then call the object. So the first line instantiates a new object of my class, my thread. Okay. So this statement just creates the object. Next, the thread that will run this object is not yet running. The thread is in a newborn state. So only if you consider these two different two statements. This one is different statement. This is one statement. So here only the object is created. The thread is not called. We are not starting it. Like if you have a bike is ready to use. You have cleaned it, you have made it ready and kept it like that. You didn't start it, right? So it is just you have bought it, you have purchased it. So it is this statement is like just creating the thread. Creating an object. In such a state, the thread is said to be in newborn state. Newly born state, newborn state. So the second line calls the start method, causing the thread to move into the runnable state. So after starting the, after calling the thread, after calling the object through this start method, after instantiating the thread, you have to call the method. Which method? Start method, in order to make the thread work or run. So this second line causing the thread to move to the runnable state. So these are the states that you have to keep in mind. Newborn state, again we will discuss them in detail in the next class. So what are these? Newborn state, when the thread is only created. It is just created. No work, or it is not started. It is just created. So it is called newborn state. So when you call the start method, when you use the start method, when you excuse me. So when you call or using the start method and you call the thread, or when you call this method, it is called said to be in runnable state. It will be moving from newborn state to runnable state. Next, the Java runtime will schedule the thread to run by invoking its run method. So once you implement the thread and you start it using the start method, Java runtime will come into picture to invoke the run method. So when the run method is invoked, so here run method is not invoked in these two states. First it is created and next it is started. Now the invocation of the run method takes place. Now the thread will move to the running state. So it will have three states: newborn state, runnable state, running state. So this is the actual state where the class is getting executed. I mean the code which is written in the run method is getting executed. So see here we will see an example of how to create thread and how the output will be. See here we are creating through three threads to the main class A, B, C and C. We are creating an object for the thread A and you are using the start method. Okay, see A, these two statements can be combined together to into this single statement. New, I mean these two dot start. So you can remove this part which is on the left side. Okay, so this can be written compactly as new a a class, which is A is nothing but a thread class created by us, and dot start, we're calling the start method. So immediately after the thread A started, there will be two threads running in the program, the main thread and the thread A. The start method returns back the main thread immediately after invoking the run method. So the after invoking the run method, sorry, after excuse me. So the start method, which is used for invoking the run object, uh, is will come. I mean, the control will come back after invoking the run method of the A class or A thread class back to the main method, and it will start the thread B. Okay, so this is what we are seeing. The start method returns back to the main thread immediately after invoking the run method. So एक बार run method invoke हो गया, I mean you invoke the run method, the control will switch back to the main thread. So creating threads using the thread class. So how do you create the threads using thread class? See, we are creating three different threads. So class A extends thread, class B extends thread, and class C extends thread. So you are taking three different loops here. I is equal to 1 and you want to print from thread A. I'm printing these numbers. Next, here you are taking another loop. Okay, from thread B you want to print these numbers, and from thread C also you want to print some numbers, and finally you exit from these three threads. So it's simple, and you from thread main method you're calling all these three. So new dot A start, new B dot start, new C dot start. So this is a compact way of combining the method, sorry, instantiating the method and calling the, making them using the method to run the start method. So this is how the output will be. See here. So first run, it will from thread A, it will print 1. Next from thread A, it will print 2. Meanwhile, it will jump to thread B, okay, and it will execute these values, and again it will jump to thread C. Again, it will come back to see how the uh, time is getting distributed between these threads. So some time for A, some time for B, some time for C, again A, B, C, again A, because with this printing of I, the loop has completed, so it will exit from A, it will exit from the A thread. Next from B also it will uh, print the fifth last iteration and exit from B, and finally it will print the last a number from C, and it will exit from C. So this is how actually the threads will run. See, we have executed two times this program. This is the first run and this is the second run. If you compare these two outputs, these outputs are not the same. See, the execution order of execution of these threads is not same. So there is no hard and fast rule that they will follow any order. The thread execution will follow any order. They can follow any order because the control will shift between these threads, and it gives us an illusion that they are run parallelly. So if it starts C thread, by the time the main thread has reached the end of its main method, there are total of 4 separate threads running in parallel. See. They do not follow any specific order. They are running independently of one another, and each executes whenever it has a chance. So whenever the control is given to that thread, and how that control is given, again we have to discuss it under a separate topic called thread priority. So that is the reason the output of this run and the output of the second execution are not one and the same. So depending on which thread gets the control for execution, that thread will be printed. So here first A is printing, next C is printing, next again A is printing, and then comes B, next C, next A. So this is how actually the execution is taking place in the second, what you say, second run, when you run the program for the second time. Next, stopping and blocking a thread. So this is also one more important point of your thread. So you have to start the thread and you have to run the thread. Okay, so in order to make the thread run or implement it, instantiate it, to execute it, you have to use the start method. So start and run are the two important methods of the thread. Next, you have to stop the thread. So if you want to stop a thread from running further, and you want to stop its execution. See, once the execution completes, it will end on its own. It will stop on its own. But if you want to stop it explicitly, when you want to stop it, then you can use this a thread dot stop. So when you use this method stop to stop the thread's execution, then the thread is set to move into dead state. Newborn state, runnable state, running state, and the fourth one is thread dead state. Okay, so this is the dead state. So a thread will also move to the dead state automatically when it reaches to the end of its method. So when the execution of the thread completes, automatically the thread will move to the dead state. But if you want to explicitly put it into dead state, then you can use this stop method. So simply you can call it as premature death of the thread. Next, blocking a thread. A thread can be temporarily suspended or blocked from entering into the runnable and subsequently running state by using either of the methods: sleep, suspend, wait. So these are the methods you will be using to block a thread. Say for some reason I want to block a particular thread from running for some time. I don't want to kill it. I mean, I don't want the thread to die. I don't want to kill it. I want to wait it. I want to put it in some hibernation like thing. So then I want to make it idle for some time. So in such case, you will be using this three methods depending on our requirement: sleep, blocked for a specified time; suspend till we give further orders; and wait. When some condition occurs, automatically it will come back to its or runnable state. So these methods will cause the thread to go into blocked or not runnable state. So again, when these methods are used to bring back the thread to the normalcy, you have to use the corresponding methods. So sleep से लेके उसको resume करना है. When you suspend it, you have to sleep when it is put to sleep by using the sleep method. It's like after some time, after if you set the time, after the time elapses, I mean when the time gets finished, like 5 seconds or 10 seconds or 15 seconds, automatically it will come back to the runnable state. So there is no method is required to take back this method from get back the method from sleep state into the runnable state. So if you just specify sometimes here we already see it here block only for a specified time. That means you'll specify the time for which the thread has to sleep. Once the time elapses, I mean finished, it will come back to the runnable state. Like the resume method, to get back to the runnable state, to get back our run thread to the runnable state, you can use this resume method. Suspend का के साथ कौन सा method use करना है? Resume method. Next, wait. So when it is waiting for a condition to occur, you can bring it back to run method, runnable state by using this notify method. These are all the things that you have to remember to perform the operations on a thread. So these all will form the different states the thread is going through will be constituted into a life cycle of a thread. So we will see what the life cycle of a thread is and how it will be shifting from all these states from one state to other state by using these methods in detail tomorrow. So if you have any doubts, bring me in the group.